Everyone, I hope you are doing well. Today I will explain the second homework that was assigned to us. And this one is very interesting because we are given the hexadecimal values that we have to convert, and after that we are gonna see how it works. Okay, so it may sound a bit hard right now, but it's gonna get easier once we start. I'm gonna I've opened the PPT, and once I have the uncertainties, we are just gonna look there because even though do remember the uh, everything, but still, I decided to keep it open just in case. Okay, so I'm opening the. I cannot copy paste, unfortunately. That's why I'm gonna write it manually. So let's write it down. So the first hexadecimal number is E3A01. Let me check it because I'm scared that I'm gonna write it wrongly and everything's gonna be wrong. Okay, so this is what we got so far. I'm copying it and pasting it here. Yes, so what do? We just basically, let's firstly divide it here and see what it means. 1110 basically means that condition all conditions are met. Then we have 00. 00 basically means it's data processing instructions. And then we have 1. When it's 1, it's the immediate value. When it's 0, basically it means that it's no immediate value. Okay, then what do we have? We have 1101, and 1101 basically means cmd move. So we have our command move, and we know basically what it's like. We know the core right now. Then we have vote. We have the this when it's like flag changing information. When it's 0, it basically represents no change. When it's 1, it represents a change. Okay, then what do we have? We have rd equal to r1, and basically crc2 is 0 and mov r1 is also 0. Yes, so I think it's more or less ready, and let's write it down to our CPU later. Yes, so basically the command that we got is mov r1 and 0. Basically what it is, it basically gives value of 0 to r1, which is our register. Let's move on to the second one. The second one is this one. And 1 second, let me. Yeah. So it's E3A E3A 0200A. 1 second, let me be sure that I've done it correctly. Yes, it is correct. 1 second. Yeah. It is correct. So let's write it here. Okay. So basically let's divide it immediately. 4 from here, 2 from here, 1 here, 4 here, 1 here. Yeah, 4 from here and 4 from here. Yes, and let's start our analysis basically. So again, what do we have right now is they're basically the same. It basically means that all conditions are met. 0 0, both of them are the same, which is data processing. 1 1, it's the same here too, which basically represents immediate value. Again, they are the same, which basically means that our command is move. So I understand that like both commands are move. And 0 0, it basically flag changing information is the same, no change. So the only difference that I see is here and in here. So here we had R1, but however here it's gonna be R2 because we have 1 here, and the value that we have here is 10. So our SRC2 is source 2 is 10. So let's write it down. Let's write this thing down. We have mov R2 and 10. So basically what it does so far, it basically gives the value of 10 to R2. Let's move on to the third one. So I'm gonna write the third hexadecimal number, and let's see what happens. Yes, 3A 03 1 2 3. Okay. So this is our third one, and again let's divide it and see what happens. Basically what I noticed is that these patterns are the same, which basically means that again it's gonna be mov 1, but we have some changes, and these changes are here, which basically means that we have mov R3 and 0 because we don't have anything here. So let's write it down. Let's write it down. Yes, so I'm writing mov R3 and 0. 1 second. Yes, 0. We basically give value 0 to R3. And let's move to the fourth line of our code, which is again E3A 04 005. And let's see which value we get so far. Okay, let's copy and paste it. Again, guys, as you can see, it's basically the same. So what can I conclude is that they all are mov conditions, and the only thing changing is these two last parts. So what do I have here? Here I have R4, and this part is 5. So let's write it down. We basically write mov R4 and giving the value of 5. Yes, so let's move on to the next one. So we have done 4 of them, and we have the remaining ones. So we have this. Let's write it down. Okay, so we have E05350004, and let's convert it. 1 second, let me check it so that it's for sure. Yes, I've checked, it's correct. Yes, so it's our 5th line, and let's see. Let's again divide it. 4 2 1. Okay, so what, as you can see, again, it's like condition or all conditions. It is data processing, and we have changes here, which basically means that it's no immediate value, and we have 0010, which basically represents subtraction command. So we are gonna have subtraction now, and 1 here basically means that it's gonna be triggered. It's not 0, so it's gonna be triggered. And we have our yes. What we have so far now, it's R5, R3 and R4, yes. So we basically subtract R4 from R3 and save results in R5. Yes. And then we compare R3 and R4 and update this flags. Okay, so let's write it down and see what happens. So as I've said, it's subtraction, so I'm writing subs R5, R3, and R4. And let's move on. Let's move on to the 6th one, number 6. And let's write it down. Unfortunately, I cannot copy and paste it. I really don't know what the problem is. 6. So that's why I'm writing manually and it takes more time. 0, 0, 0, 0, 2. Yeah. So that's what we got so far for the line number 6. 6, yes. Okay, so let's copy and paste it and see what happens. Okay, so here basically what we have, it is slightly different. And 1 second, let's firstly divide it and then try to understand what it primarily does. And yeah. Okay, so here we see some changes and it's like more different than the others. So firstly, the thing that I want to mention is that this 0, 1, 0, 0 basically represents add. So we are gonna add RD, RN, and CRS2. And CRS2 is gonna be 2. And this condition basically means less than. So it's not the same as this one's. That's why it's less than. And I think we are ready to write it down as a thing to our CPU later. So what do we have? We have 1 second. Yes, so we have at less than R0, R0, and R2. So basically what it is, let me quickly explain the meaning of this line. So it basically means that if R3 is more than R4 is more than R3, then R0 is going to be R0 plus R2. So this is what basically it represents. And now let's move on to the next line, to the next one. And it's going to be the 7th one. Okay, so let's write it down. It is B28 33001. Yes, so this is our value. Let's copy and paste it and let's see what happens. It is yeah, this one is low-key the same as the previous one. As you can see, these two are the same, these two are the same, these ones are the same. And the only difference that we have so far here is so it's gonna be again like add LT, but it's gonna be R3, R3 and 1 right now because these parts are slightly different. So let's write it down. Let's write it down. And yeah, let's write it down. For now, it just a bit looks weird to me, but I think it's gonna be correct at the end. Oh my god. Okay. Let's move on to the next one. I think it was number 8. So we have done the half of it. And this one is very different, guys. So it's like um, more different than the ones that we have seen before. 1 second, I want to recheck. And 3 more. 1, 2, 3. B. Okay, so it's slightly, not even slightly, it's like more different than the other ones. And I think it's gonna be more interesting to investigate on this one. Okay, so let's start. So here again, like condition is less than. Then so see guys, this one is different. We have 1 0, not 0 1, and it is branch instruction. Beforehand it was data processing instruction when we had like 0 0, but 1 0 basically represents branch instruction. Great, let's move on to the next one. So we have now what do we have now? We have 1 0 again, and yeah, this basically means B command, and let's see what yes. So here what we basically do, we take this part, change it. So for example, it was 1 0 1 1, but we are gonna write 0 1 0 0 plus 1, which is gonna give us at the end we basically are gonna have -5. So our BLT is -5, and what it does, it basically moves 5 lines back from program counter, and the label is created here, guys. So let's move. So yes, so we are gonna create the first label here. So I'm gonna name it as label 1. 1 second, yes. And then let's write down the thing that we found so far, which is BLT. Sorry guys. Label 1. Yeah, so basically what it does so far is the fact that if R3 is not more than R4, then branch goes back to label 1. Okay, so I think we can go to the next one, which is number 9. Again, it's slightly more different than we have done so far, but what can I do? 1 2 3. Okay, so 1 2 3, 1 2 3. Let me check whether it's correct or not. 1 2 3, 1 2 3. We have 3 here and 3 here. Yes, it is correct. So let's see. Oh, I copied the wrong one. Yes, so what we have so far is no condition. Again, it's branch instruction. Again, its command is BL, sorry. And yes, from here if we change it, we get -1, and instead of going 1 line back, we are gonna go 1 line forward, and we are gonna have the new label. So let's do it. So we have BL, this one BL because the commands are different. BL label 2, like we are gonna create the new label. And we are going forward this time instead of going back. So we are gonna have label 2. Yes, so let's move on to the number 10, and let's see what we have there. So we have E52 DE004. Okay, so what do we have here? Here again, no condition. 01 means memory instruction. And in memory instruction, we have to separate this. So 1 second, let me separate, and then I'm gonna explain 1, 2, 3, 4, 6. Okay, so after the separation, yes. So let's understand. So no condition, and 01 basically means memory instruction. Because of that, we are gonna separate them, and we separated this for easier. So basically, what do we have? We have immediate value. Then 1 basically represents pre-indexing, and LB condition basically means storing, and U means subtract from base. Then what we have Rn is equals to R 13, which is stack pointer, and Rd is R14, and SRS is R3. Basically, guys, if we sum it up, what we have so far, we have STR, so let's write it down so that it's gonna be more understandable. STR LR, sorry, STR LR is B minus 4. Yeah, so basically what it does, it pushes the link register LR to stack, and it is a pre-index with write back, as I've previously explained it here. Yes, so we are done with the 10th one, and let's move on to the 11th one. And let's see what it is so far. So it was E52, now it's gonna be E3A04 OOF. 1 second, let me check. E3A04 OOF. Yes, that is correct. And let's see what we have so far here. Okay, so again, let me quickly divide it, and then we are gonna I'm gonna explain the core logic behind it. Okay, so basically, again, no condition. It is data processing. Immediate value is present. Our command is move. Yeah, I think we had it. Yes, from here we know that it's move. Then we have RD is R4, and CRS2 is 15. Yeah, so basically, this one is actually easy because it locates the combination of whatever we have done so far, so nothing new is here to explain. That's why what do? We have this command move R4 and 15. What basically it does, it loads the value of 15 into R4. And let's move on. Let's move on to the 12th line. And I can see now that it basically looks the same. The only difference is 5 here, and it was F here beforehand, but we are changing it to A. Yes. So let's have it here. So yeah, basically it's the same. Again, it's gonna be no condition, data processing, immediate value present, and command is gonna be move. But the only difference here is that instead of R4, we are gonna have R5, and it's not 15 here, it is 10. Yes, so let's write it down. We are writing move R5, sorry, R5 and 10. Yeah, again, so we basically load the value 10 into R5. And let's see what we have next. So it's our 13th line and we are almost coming to an end. Let's see what is going on so far. So what we have E08 56004. Yes. Let's copy and see what happens. So as we know from the previous ones, we have to divide them. So let me quickly divide them again and explain, because it's not the same as this one. So like I'm very sure, when I'm not sure, I tend to divide and see what actually happens. Yeah. So 1 second, I got confused. 4, 2, 4 here, 1 here, 4 here, and 4 here. Okay, so what we have again, so we have no condition, data processing, no immediate value. Yes, this command is add, so the commands are different again. So we have add, not move. Then rn is gonna be R5, rd is gonna be R6, and source 2 is gonna be R4. Okay, so let's write it down to our CPU later. It's gonna be at R6, R5, R4. Yes, again, so what it does basically, R6 is equal to R5 plus R4, which is 25. Yes. And let's move on to the next one. And I can see that it's the, yeah, so I can see that this one is the same as this one. So I basically know the thing what it does, so I'm not gonna explain it. I'm just gonna write it down. So because we know that it basically does subtraction, which is here, and let me copy and paste it actually instead of writing it down directly. Yes, and finally we have the last one, the last line, and let's see what we have. We have EA, FF, FFF. So we have 5 Fs. Let me check if I wrote it correctly. 1, 2, 3, 4, 5. Yes, it's correct. 9. Copying, pasting, and this is what we have. So this is what we have so far. Let me divide them, and then I'm gonna explain. Yes, so basically what we have no condition, branch instruction, it's command B, and from here we get -7. When we add 0, 1, 1, 0 plus 1, it's gonna give us 7, so -7. And B is gonna be like it's gonna go 2, because it basically moves. Yes, so what we are gonna have, it's gonna be B label 2 basically. So let's write it down. B label 2, sorry, label 2. Yes, so what happens here basically is that branch goes back to label 2. It creates the infinite loop, which is also unconditional. And basically what is the problem with this code? So part of the homework was to understand the like why it's gonna stop basically. So not stop, like why is it incorrect basically. And the reason it's incorrect is that basically it's gonna go back as we have discussed before, and it creates stock overflow, and it also creates memory overflow, which basically means that so it's gonna repeat, which is very bad, and everything's gonna repeat from the beginning basically, which is very bad. So this is what we have so far, and hopefully it was understandable. And thank you very much for watching, and I'm wishing everyone the best new year, and success in the future. Yes, thank you very much. Hopefully my explanations were understandable. Thank you very much.